G'day and welcome to the third video in the series on applications of calculus and differentiation. This one is based on 6.3 from your textbook, which is Euler's approximation. Now, this one can get a little bit tricky in the theory of it, but the applications or the actual examples shouldn't be too bad. So if you get lost in the theory of it, just follow me through to the end when we do the applications, the actual questions, and it shouldn't be too bad. So I'm going to use this formula here, which is essentially the gradient formula. And I'm going to say that the gradient is approximately equal to, well, the instantaneous rate of change is approximately equal to this bit over here. Y2 minus y1 over x2 minus x1, or the difference in the x values. Now, I can rearrange this formula and get whatever I like, but I'm actually going to rearrange it to find out what f of x plus h is approximately equal to. And it's approximately equal to f of x plus h times f dash of x. Essentially what we're saying in words is the next y point, because that's what f of x plus h is, x plus h is the next x point, f of x plus h is the next y point. The next y point is approximately equal to the previous y point plus h, which is the difference between the two x values, multiplied by the gradient at that particular point. And this way we can actually approximate what the next y value is going to be. So imagine we have a graph here. I'm going to use a parabola, I think. Here we go, and I'll say that's the point that we've got. That's x and f of x. Okay. Now this graph here has a gradient at that particular point, and let's just say that that gradient is something like 3 or something like that. It doesn't really matter. What we're doing is we're saying that the next y value, which is some distance from here, so like it's hard to kind of show you this low, but the next point I'm going to look at is this point over here, which has an x distance and a y distance. So that next point is going to be x plus h and f of x plus h. And I've written that a little bit too small. So let me just x plus h and f of x plus h, if you can see that tiny little writing over there. Now what I'm going to do is I'm going to use this formula here to work out what that next point is going to be. I'm going to say it's the previous point, and then I add to that previous point, that y value, I'm going to add h, which is this distance between here and here, between the 2 points, and I'm going to multiply it with the gradient at that particular point to find the next value. Now it's going to be an approximation because I'm not going to find the exact value because the gradient changes all of the time. But what I am going to find is I'm going to be able to find, if I do this equation here, I'm probably going to find the next y value to be about there or something, which is not quite exactly the same y value. In fact, it's a fair bit off, and the further away h is, the bigger it's going to be off, because h changes because the gradient changes all of the time. But that's essentially where my next y value would approximate to be. Okay, so that's kind of what we're trying to do with this formula. I hope that was clear. If not, I might explain that a little bit more in class. But I guess now we just probably need to have a look at some questions, to see how we can go about this, because the theory of it, you don't really need to understand that much. You just need to be able to do it. Essentially, it's just using this formula here to approximate the next y value. Okay, so let's just jump to a question, and we'll cover the theory a little bit later if we need to. So here's an example. I've got my graph is f of x equals x squared plus 1. And I know that when x equals 1, I guess by using x equals 1, that's the point, I want to find an approximation for this particular value here, 1.01 squared plus 1. So I can't use my calculator, I have to find an approximate value for that one. So essentially what I'm saying is, when x equals 1, I know that x plus h equals 1.01, because that's the difference between, if I substitute x as 1 here and then I substitute x as 1.01, the difference between the two is 0.01. So h is 0.01, x is 1, x plus h is 1.01. Hopefully that makes a little bit of sense. I need to know a bunch of other information. I need to know what the y value is at when x equals 1. So I substitute 1 into there and I get 1 plus 1, which is obviously 2. I also need to know the gradient, f dash x, which is in this case 2x, and I need to know the gradient at the point x equals 1. So I put f dash of x, f dash of 1 equals 2 as well. And now I can put it into this approximation formula to find out what the y value is when x is 1.01. Okay, because essentially that's what I'm trying to work out. So that one there is 1.01. Okay, what is the y value when x equals 1.01? Okay, so I can put all of this information that I've found in. I don't know what f of 1.01 is because that's what I'm trying to find out, but I do know that it's approximately equal to f of 1 plus h times f dash of 1. So I found out all this information over here. F of 1 is 2. Where did I find that? Oh yeah, here we go. F of 1 is 2 plus 0.01 because that's what h is, multiplied by 2 because that's what f dash 1 is, and I end up getting 2.02. So an approximate answer to 1.01 squared plus 1 is 2.02. If I actually try and find out what the actual answer is, I can do that on my calculator, and I get 1.01 squared plus 1. My actual answer, as a decimal, is 2.0201. And I got the answer of 2.02, which is pretty good. It is an approximation, but it's a pretty good approximation. The closer h is, the better the approximation is, because the gradient changes all of the time. Okay, so hopefully that's explained, or that's shown you what you would need to do. Here's a question I've grabbed from an exam. It says, using the approximation formula, f of x plus h equals f of x plus h times f dash x, and f of x equals x to the power of 4, what's an approximate value for 3.95 to the power of 4? Well, let's just have a look at this for a second. 3.95, that's a bit confusing. That is going to be my x plus h value. So I can tell you that x plus h equals 3.95 because that's the next point, and I don't know how to do that. But what I'm going to do is I'm going to try and use something that I know, which is sort of similar. I'm going to use x equals 4. Okay, because I know what 4 to the power of 4 is, but I don't know what 3.95 to the power of 4 is. Okay, which therefore that would mean that h equals negative 0.05. Okay, so I'm actually working out the previous y point, not the next y point. Okay, so now I'm just going to go about and do this whole question. So I know I need to know all of this information. F of x equals x to the power of 4, x equals 4, x plus h equals 3.95, and I've sort of worked out some of that stuff before. I need to know what f dash x is. It's 4x cubed. Okay, and so now I need just to put this into my equation, which I had up the top, and I should be able to find it. I don't actually need to work out the numerical answer for this because the answers in the that I've been given don't actually have a numerical answer except for E, but I don't think E is correct. So what I can say is that 3.95 is actually approximately equal to, that should be an approximate, is equal to the the y value when x equals 4. Usually it's a plus, but in this case it's a minus because h is actually negative. So minus 0.05 times f dash of 4. Okay, and this will get me an approximation to what the y value is when x is 3.95. Okay, so this is the previous y value minus h times the gradient at that particular point as well. So the answer to that question, I guess, if I have a look, would be D in this case. Okay, and I could actually find out what the numerical answer to that was, but in this case I don't need to. Now hopefully that's given you some insight as to how to apply the approximation formula. I think the key points in all of this are finding the things that I've tried to find before, but you're given f of x, you're usually given the value of x as well. So you're given those two things, not always, but you're often given those things, and you're also asked to find out what f of x plus h is. Usually you'll have these three things. You'll have 1, 2, 3 things. The things that you won't have is that you won't have h, and you probably won't have f dash of x either, and so I guess you'll need to find those two things then to be able to put them into the formula. Okay, so what I find helpful is I find it really helpful to write down all of these things here, and then I can kind of tackle the question after that. Okay, so there are lots more questions that I could go through in class if you're still needing a little bit of assistance and help with this, but otherwise enjoy 6.3. Thanks.